Hi, folks. We're going to take a look at page 112, number 19. So take a look at question here. And essentially what we have is we have a sheet of paper or a sheet of cardboard. Okay, here 32 centimeters by 28 centimeters. And we're going to use this to create an open top box. And the idea here is that we cut off equal sized squares from each corner. And from there, you should be able to create a box. Let's take a quick look at what that would look like. So here you see that I cut out equal size squares, and all I'm going to do is fold up that and then create a side. And then same thing here. I'm going to fold this up and eventually I'm going to create a box. Okay. Now, one thing I notice is that they don't tell me how big this square is. So that's going to be my variable, presumably, or at least certainly one of my variables. But notice that whatever the length of what I'm cutting off is for this square, when I fold it over, is now going to become my height. All right. So let's look at how we can solve this problem. And of course, notice that they give us some extra information. They do tell us that the box has to have a volume of 1,920 centimeters cubed. So this is what we call our constraint. All right, there could be more than one box that we can create, but it has to meet this constraint. All right, so let's see how we can solve this problem. Okay, so I've got to set it up here. And as we talked about, what I don't know is how big a square I'm cutting off. But because it's a square and that they're all the same, I know that this length, I can call it x, and then this would be x, and this would be x. And each of these side lengths would be x. Okay. Now remember what happened here is we're going to be folding up this side. We're going to be folding up that side. So this will represent the length of the box. Okay. And what we have is the total length of that cardboard, but I've cut off a little x here and I've cut off a little x there. So this can be represented by 32 minus 2x. Similarly for the width, I'm going to be folding this part over. I'm going to be folding this part over. So what's left for the width of my box is going to be 28 minus 2x. And remember what we talked about is this length of the square that I cut off when I flip it over is just going to become my height. So the height of my box is just going to be x. So now we have a representative for the 3 dimensions of this box, which of course is going to be useful or should be useful because the information that they give me has to do with the volume of the box. And we know that volume is length times width times height. Okay. So what we know is that we need our box to have a volume of 1920, and that's going to be represented by my length, 32 minus 2x, times my width, 28 minus 2x, times my height, x. And look what we have, an equation. It's a polynomial equation because if I multiply this out, I'd have a cubic, okay? And it might even look like a particularly nice equation because when I look at that right-hand side, hey, look at that, it's in factored form, okay? Now, I hope you see that there's a problem here because while it is in factored form, it's not in the structure that's useful for us. Because factored form, having a product of expressions, is only useful to us if the other side is equal to 0. Okay? And we know that when we don't have one side equal to 0, what we have to do is move everything to one side, okay, and get 0. So that means we're going to have to actually distribute this whole thing. Bring the 1920 to the other side, and then we're going to have to refactor. But what we have now is the equation that we're going to be solving. Now, which side do I bring things on? Well, I notice here if I multiply the two, negative 2x times negative 2x, it's going to be positive, times the x is going to be 4x cubed. So since I have a positive leading coefficient, I'm going to bring everything to the right-hand side. Okay, I always want to have a positive leading coefficient. So I have 0 here. So let's start multiplying this. So 32 times 28. I'm sure if we tried hard, we could do it in our head, but let's just calculate it here. So 32 times 28 is 896. Okay, I'm going to multiply these two first. So then what do we have? We have 32 times 2 plus 28 times 2. Notice I'm adding them because they're going to be both negative. So in terms of the calculation, it'll be the same, but it's going to be minus 120x. And then here, as we said, plus 4x squared times x. And don't forget that we're bringing over the 1920. And so now we can clean this up. All right. So what do we have? We've got, we'll put the 4x cubed up first. Then we've got the minus 120x squared, because I have to distribute this x to everything, then plus 896x and minus 1920. And looking at these numbers, they really all look like they're divisible by 4. So I'm going to divide by 4 to both sides so I can get a simpler polynomial here. So this is going to be x cubed. This will be divided by 4 minus 30x. This one again, sure, we could do it in our heads, but let's not take a chance. 896 divided by 4 is 224, and then 1920 divided by 4 is 480. Okay, and let's take a quick look here, see if the grouping works. But when I factor out, oh, that's supposed to be x squared. Again, this is going to be x squared. Sorry about that. If I factor out my x squared here, I'm going to have x minus 30. There's nothing I can factor out in order to get x minus 30. So we have no choice but to use the factor theorem. Okay, so let's do that work on the side here. So let's say I call this polynomial p. Okay, so 1 minus 30, negative 29, plus 224, minus 480, absolutely can't be equal to 0. I'm not even going to bother calculating its value exactly. Okay, now this is where I'm going to do something different, because one thing we have to keep in mind is that x is representing a length, so it definitely needs to be, I'm only going to accept positive answers. And while it's possible that one of the x-intercepts might be negative, and I might get a positive one that would work, I think I'm going to hope that there's a nice positive x-intercept here. So for this particular case, I'm just going to stick with the positive factors of 480. And, like I said, I'm taking a bit of a risk, but, because I'm hoping there's a nice positive factor, nice positive x-intercept, I'm going to go with that. So here, now I'll get my calculator out. So what do we got? We got 2 cubed is 8, minus 30 times 2 squared is 4, plus 224 times 2, minus 480, okay, not equal to 0. Okay, so 480 is divisible by 3, so let me try 3. So 3 cubed is 27, minus 30 times 3 squared is 9, plus 224 times 3, minus 480. No, still not 0. So let me try 4, because that's also a factor of 480. So let's try this here. So we got 4 cubed is 64. Of course, do that on your calculator if you're worried about making an error. Minus 30 times 4 squared is 16, plus 224 times 4, minus 480. Oh, there you go. That one's equal to 0. Okay. So now I know, and notice how I write it out right away. I don't want to forget this x minus 4 is one of my factors. Okay, and now let's do a synthetic division to calculate the quotient. So what do we got? 4. So here we have 1, negative 30, 224, and negative 480. All right, so the 1 comes down. 1 times 4 is 4. Negative 30 plus 4 is negative 26. 4 times negative 26. Again, I can do that in my head, but you know what? I don't want to take any chances. So what do we got here? We've got 104. Okay, and it's actually negative 104. 4, so here there's 4 minus 4 is 0, 2 minus 1 is 1, 120. 4 times 120 is 480. So there we go. I do get my remainder of 0. So that tells me I'm probably doing something right. And so now my quotient is going to be x squared minus 26x plus 120. Okay. And right away, I say, oh, 120. I know 120 is 20 times 6. And look what we have, 26. So it looks like this is easily factorable. Okay, we don't have to go to the quadratic formula here. So it looks like this is going to be x minus 6, x minus 20. Give a quick check. Negative 20 minus 6, negative 26. Okay, 20 times 6, 120. And so that means x can have 3 possible values, and they're all positive. So that's good. We can have 4, we can have 6, and we can have 20. So we might think that there's 3 possible boxes that we can produce. But there's one of these that I really don't think is going to work, because look at this, width here is 28 minus 2x. 28 minus 2 times 20 is going to give me a negative number. So while 20 solves the polynomial equation, it is not a valid answer for the particular scenario I'm working with. But it looks like both 4 and 6 will work. So we've got 2 possible answers here. So let's look at possibility 1. So our length is 32 minus 2 times 4. So what is that? 32 times 8. 32 minus 8. So what does that give us? Minus 8. So I guess that's 24. 24 centimeters. Our width is 28 minus 2 times 4. So that's going to be 20 centimeters. And of course, our height is just the value of x, so 4 centimeters. But it looks like we also have option 2. So length is equal to, 32 minus 2 times 6. 32 minus 12 is 20. Very interesting. They happen to be the same. Let's see what happens now. We've got our width. 32 minus 28 minus 2 times 6. And what do we have? 28 minus 12, 18, so 16. So while we do have one dimension that's the same, this is going to be a different box. Sorry, just make sure you can see that. And then finally, our height is going to be equal to 6 centimeters. So we can create an open top box in 2 different ways, and they will both meet the condition that the volume is 1920. Just for the fun of it, if you want to give a little check to make sure you didn't make any silly mistakes, or sorry, I didn't make any silly mistakes, I guess. Let's do 24 times 20 times 4, and there you go, 1920. Let's do 20 times 16 times 6, also 1920. So let's do a quick recap. So step number 1 here is we had to determine what equation would solve our problem. So it was understanding what expressions would give me the length, width, and height of the box so I could use my volume formula. Step number 2 was to identify that this equation, while one side was in factored form, was not useful. I needed to re-expand and rewrite it as a polynomial equation with 0 on one side. Then from there, I followed my factoring method for determining x-intercepts, and then I chose the x-intercepts which were reasonable for the problem I was solving. That's it for this one.